building today can somehow question the idea of the sealed block somehow, something that is closed, something that is looking inwards into the building, but trying to be multifunctional and trying to be somehow open to the city in terms of how the building touches the ground, in terms of the function, in terms of the accessibility, with many problems that were somehow faced. And so maybe we'll leave these considerations for later. For the moment, I leave you the floor, and then maybe we can discuss a little bit about the different aspects that come out from the work. So is yours? 25 minutes?
Dear professors, families and friends, welcome to the Greenwich Tower. I would like to start my presentation by a phrase from Lecco. 100 times have I thought New York is a catastrophe, and 50 times it's a beautiful catastrophe. Like the 8 million inhabitants searching for their fortune in the huge metropole, when we were searching for our option for our thesis subject, this competition by Özcan, offering the creation of a mixed-use skyscraper in one of the most attention-breaking spots of the city, was an inevitable choice for us, for combining our cosmopolitan identities as a group members and our European system-based education background. As New York is the most Googled city of all times, we were already familiar with the working and not working aspects of the city. And of course, it is not as efficient as making a side tour, but we even have squeezed a little side tour into this limited evaluation process. So I would like to present you some squares from New York and our final rendering of Greenwich Tower. More attention is drawn to the spot of downtown Manhattan after the 9/11 incidents. The debates about mixing usages between offices and residences, the safety problems going on in the district in the night, the problem of waste energy consumption going on in big American cities are continuing whilst we are talking, so that we are here to share our ideas about the new concept of skyscraper into a city with an old history of skyscrapers. As a summary, we have tried to mix the American trade of commerce into the European idea of sustainability by a common sense for the realizationability of the project and aesthetics. The spot already offered us the views, the connections and the potential already, and what was left to us was to package our sustainable ideas to an envelope not only attractive to the possible investors but also for the community of people living in and working on the building. One of the biggest debates we had through our design was about the green. The architect Eymir suggests to use as much as green in a building as its base area consumption by concrete. The architects love green because it's simpler, sustainable, alive and deep. But the owners refuse it because it's not money-making due to the space loss. What about the normal people? Maybe that is the question that we usually forget to consider in the evaluation process. That's why we gave a functional identity to green, as important as the other function. But to give a meaning, the green in the Greenwich Tower offers you a pleasant walking tour from your home to work, or a comfortable picnic area for the weekend with your children, or your own urban farm just 2 stories down your apartment, to grow your unhormoned organic food. The architects are happy, the investor is happy, and most important of all, you are happy. So this is the summary of the zoning, the financial district, and the Better Park City, mostly residential and offices. And this is the platform summary and the views of Statue of Liberty. The facts about the building and the numbers approximately.
With the urban design part, what we basically did was to cover the Brooklyn Battery Tunnel with a green platform, creating a new park. The area is located in Lower Manhattan, in the district of Greenwich South. We can see the development of this area through the years. Our main neighbors are the Wall Street, the World Trade Center, the Battery Park, and the Battery Park City. All these sites are 5 minutes walking distance from the center where our tower is located. We don't have green areas inside our zone, but we have a few close to it. The scale of the area is about 11 Piazza del Duomo. As well as the whole city, it's well served by public transportation, but we wanted to increase the bike routes to encourage people to bike and walk. The SWOT analysis, what we got is that our weakness is the existing tunnel, but at the same time is our opportunity because we are creating a new public space.
So for our design, we set some goals. And first goal, as we mentioned, was to create a mixed use because, as you know, our Greenwich neighborhood is just in between a workplace and a living place. So we wanted to create a place that combines work, live and play, and that brings all together into one zone. For this purpose, after closing the tunnel with a platform, we started to try to foster the growth of a diverse economy by, first of all, creating some little shops along the street which serves for 2 levels, for 0 level and for the platform level. Then we opened a street right in front of our building which will provide an easy access by taxis and by cars. And the third one was to create a Wi-Fi zone on top of our platform. And finally, we created a bike lane, which also provides a bike parking that combines the existing route. And the second aim was to reconnect Greenwich Street because, as you see, Greenwich lies on a lane which has many important spots, but Greenwich hasn't deserved its right value. For that purpose, we made the Greenwich as a main street, and we created shops which would provide a 24 alive street. Then we wanted to create east and west. For this purpose, mainly we wanted to connect the 12th Avenue, which is really big, has a tunnel, and the accessibility is really difficult. And for that, we created a ramp that is also accessible by the bike and pedestrians. And last but not least, we wanted to create a reason for people to come here, but not only to come here and stay here. For that, first we opened an open-air cinema. So when you sit here, you can watch your screen, and you can have both your movie and also the Statue of Liberty view. Second, we created a hill with waterfalls that would give a green experience in the center of a metropolitan city. And then we created a staircase. As you might know, in New York, stair has a special meaning. Especially, this stair is a light structure that hides the metro exit, and plus it has a bike park. And finally, we created some water fountain plus monuments that is really fashion right now in New York.
Okay, continue with the architectural design of the tower. We are doing the skyscraper in the site of a garage building here that we are going to demolish. Here it's another garage building that we are redesigning but keeping the same function. Oops. We have 2 main concepts. The first one is the mixed use. Our tower should be a piece of a vertical city. And we want the presence of people in the building in different schedules for different uses, but at the same time they can share some facilities in common. The second concept is about the green areas. We are using the green as a function with the same importance as the other ones. So we have main green floors along the tower. but we also have pieces of green areas in each floor, and they are all connected through the facades. We want to introduce also the concept of urban farm. That means we will rent these pieces of land for hobby farming purposes. This is our final volume. We decided for a regular shape. So the tower has a commercial base, and the top is commercial as well. Then it's divided in 5 blocks, divided by the public green floors. Each block starts with offices floors, and then it finishes with residential and hotel, except on the last block where we mix all the 3 functions. The accessibility. The commercial base has its independent circulation. So for the tower, the elevators are on the floor, separated by function. It means if you get an office elevator, you cannot access the hotel area, even if they are in the same floor. We have the chance to switch to another group of elevators in the public floors, because they have sky lobbies for each function to control the access. The secondary elevators are for the green areas in the south and west facade, where our farm zones are. Module, we started the plans creating the service core, and then a 3x3 grid. 3 meters because we fit a hotel room, and also because of the millions of the facade of 1 meter and a half. This is the accessibility on the ground floor. On the south is the main entrance of the skyscraper, and from here you can access the public commercial base, the public elevators, the offices lobby, the hotel lobby. The housing has a private entrance, and here we have street shops. Here service entrance and parking entrance. The underground floor, how it is. The underground, we have a mechanical parking system. The underground, you can access the ground floor through stairs, or access the public green floors through the public elevators here. The first floor, we have our food court, because of the lack of places to eat in this zone. We are making this connected to the platform level here. The second floor, we start the shops, and it's the same into the 5th for the commercial base. This is one example of a green floor. So in this one, for example, we are proposing a jogging circuit. These public floors are supposed to be used by all the users of the tower, as well as visitors. This is a preliminary zoning of the functions of the tower. This is an example of an office plan. The companies usually prefer an open plan layout, and also the floor height required for floors is higher. So due to these functionality reasons, we make these all offices plans in most of the cases. In the other cases, we are mixing housing and hotel, because these 2 functions have similar needs and same floor height. Here's an image of an apartment with garden. All the green areas in the east facade are private use. It means they are not connected between them. So the garden will belong either to the apartment or to an office, depending on each case. We have 2 floors that guests of the hotel and apartment residents can share some facilities like the pool, the gym, the sauna, nursery. In the last block, we finally can mix all the functions, all the 4 functions. The floor height is higher, and they are the upper floors. It's with the best view, which means that we have more expensive apartments and hotel rooms. The offices area is also different, because now we have smaller rooms, for example, for lawyers instead of the big companies. This is the top, it's a triangular closing, it's a continuation of the green paths. It creates a peculiar space, ideal for a coffee shop with different levels. Here the facade orientation in our conception. The apartments deserve the best solar orientation, so most of them are in the south and in the east. We use the north mostly for hotel rooms because they are used at night. Here is study of patterns for the facades, and this is how it looks like in the end.
And so the technological design. First of all, we wanted to create some boundaries for us, which we use the LEEDs. As you know, LEEDs is the system that the United States uses for a green design. It has different levels, and they get these results according to sustainability of sites, water efficiency, energy and atmosphere, material and resources, indoor environmental quality, and innovation in design. And our first target was to minimize the building energy requirements through construction measures, which mean the building shape and the envelope. For this purpose, we needed to go through all the data that we could find. And we started designing our system for an efficient technological system. For this purpose, we started defining the orientation and shape. The shape was, for simplicity, was a square. Then we turned into a rectangle for a better saving of daylight. And we gave south to house and green and north to hotel. And for the design of the facade, we started using Ecotech. And first we started doing some calculations for single glazed window with an aluminum frame on the model that we created for a single floor. And after the calculations, we calculated the same system for double glazing low-E windows because we wanted to have a whole glass facade. And after these results, we compared them and we saw, of course, double glazing, low-E windows would give much better results. And for solar protection, since we have whole glass facade, we needed to find some solutions. And first solution was fritted glass. And the second was movable doors, because we have 3 different types of usages in our building. We didn't want to fix one type solar protection in our system. Then we started to look for energy sources, and we saw that the main energy source for our building can be New York steam system, as you may be familiar with this picture. Then we said, okay, we can use geothermal energy, which is a clean energy, and a main energy for our building is solar power that we are going to create from our fritted glasses. This is a new type of energy source which just started to implement to the buildings. And another thing that we tried to save was water, especially drinkable water, because as you can see, a normal household spends so much drinkable water, which is really important for us. So we set some measures, like we use lavatory flushes with economy sewage, and then water conserving taps and shower fittings, in public sector places fitting with infrared sensors, and waterless urinals, because as you can see, toilet flushes spends the most. And we said, okay, we should use rainwater and black water. For this purpose, we created a black water treatment at the base of our skyscraper, and this tank would treat the water and send it back to the top and collect it as a grey-water, which would be used later in the lavatory, in the flushes. Also, we collected rainwater at the rooftops, and we send it back to the same tank. We created another tank for drinkable water in order to prevent any problems because of the pressure. The main problem actually in our building was the building service design, because we have three different types of usages, so they need different service system. But we decided to use all-air system for the whole building for simplicity. And to go more into detail, for example, for office we use underfloor air distribution, and it would be the core was in the center and then distributed to the whole floor. The air can be distributed to underfloor and then collected from the ceiling. And when we come to the details, as you see, the slab is a normal slab which is mainly used in the buildings. But our innovation was creating a facade which would look different from outside. So we used silicone double glazed window, and plus we wanted to create a metal, reflective metal especially, that would take the light and diffuse it like a disco ball actually. And since we wanted people to do their farming inside the building, we created different type of soils for different type of usages. And since not many people know how to do their farming inside the building, we set a guidance for them. So what they can create, what they can produce inside the building, and which type of soil they need to use. And also, we gave openable windows to the green for better natural ventilation. So, in order to, when we summarize everything, as you can see, our energy consumption was so high at the beginning when we started with a square building. Then we turned it into a rectangle and decreased the energy consumption. And with openable windows inside the green spaces, we created natural ventilation. And we produce treated glasses, and from these treated glasses we produce solar energy, and finally we collected the water and we almost decreased our energy consumption to half.
Okay, so since there is a more technical and detailed analysis for the structure in the thesis, I want to go on with the more outstanding facts about the structure. So, as a summary, this is the final report of the whole structure. Basically, as a system, we used hybrid tubing system core outrigger, which I'm going to explain basically what it is, with composite concrete cast on site metal deck, over the European steel section I-beams, and connecting to a reinforced concrete shear wall and 1.5 meter square composite and reinforced concrete encased composite steel beams. We used European sections and materials, but we used as Wyden's American standards. So, why tube-in-tube system, and basically what tube-in-tube system is? For buildings over the 40 stories, which Greenwich Tower is 60 stories, the concrete as the vertical elements is more efficient than the steel systems. But steel systems, of course, have the lightness in the horizontal elements. So, for optimizing all these facts, we have chosen to have steel beams connected to concrete vertical elements. And since steel is cheaper in the United States, it is already a good application. So basically these are the detailed drawings and examples of the slabs, composite slabs, and beams as outriggers connecting like pin connections to the columns. And the column details and connections, and the shear walls. So since it is a system, mixing of systems which requires good laborship, this is an example of the construction sequence, and it needs qualified laborship though, for all these systems. So these are basically the loading cases recommended from the American standards. And the gravitational loads are more critical, of course, for the beams and slab structures. And of course, for the vertical elements, it's the wind which defines the dimensions of the structures. It is different from other cities because New York isn't an earthquake critical region, so wind loadings on the facade are usually more critical. In reality, for the secondary structures for the facade, there has to be a wind tunnel analysis, but it was out of the scope of this course. And these are the critical loading cases and distributions on this. So basically, the plans are 3 different beam plans for 3 different types of floor systems: under house, office, and double floors, which is double floor has a maximum of 500 centimeter depth of beams because they are more critical as there is more people staying on. And so this is the structural model done by SAP 2000 program, and these are the most critical analysis results and loading cases, which W corresponds to the wind and dead load and live load. So this is the total weight of the building, which looks a lot, but it is normal for a structure of 60 stories. And the most critical loading cases. So we have applied these checks for the beams, columns, and other elements. So these are the details which are provided after the checks. So basically we have all the columns connecting in the same mode since they have the same directions, and the outrigger beams connecting to the main beams on the outer structure. We have 2 types of different connections between steel and steel, and since we have diagonal beams connecting, they are connecting onto the outer core of the concrete columns. So these are in detail how they work. So in reality, for the foundation, there is a whole group of engineers working. So this is a basically rough estimation of the foundation. We prefer, although in New York it's not necessary to have pile foundations, we have preferred it for technological aspects and also for excessive overturning moments. So this is the rough estimation of the foundation plans for the building. So this is the final result after all of the evaluation